Hello, and a very warm welcome to one and all present here. Thank you all for joining with us today. I'm Vanshika Mahajan, being the moderator for today's session on Reimagine the Cloud journey presented by Pathmakers. So, without further ado, let's get started. I would like to welcome our first speaker, Mr. Prashant Jain. Prashant is currently working as a senior director of engineering and is working from Richmond, Virginia. He is having an impressive 11 years of working experience with Impetus. He is leading some of the key Impetus clients engagements in areas including data platform modernization, cloud migration, data warehousing, and analytics. So over to you, Prashant.
Thank you, Vanshika, and hello, everyone. So today, I'm going to cover a brief introduction of who we are and what we do. So we are on a mission to empower the enterprises with a data-driven approach for their business needs and to support them in their journey to the digital transformation. And today we are steadily and efficiently solving the analytics, AI, cloud puzzle for several organizations and enabling them to drive unmatched innovation and growth. Here are some quick facts about Impetus. We are headquartered in Los Gatos in California with a very large presence in Phoenix. We have an office in Vancouver, Canada, and in India we are at 6 different locations, which includes Indore, Noida, Gurgaon, Bangalore, Pune, and Hyderabad. As of today, our organization has a combined presence of roughly 3,000 people, and our team of experts engineers bring breadth of skill, knowledge, and experience across all aspects of digitalization. We are among top 100 great places to work in India across sectors for the last 7 years. And not just that, we are among top 25 great places to work in India in tech since 2019. Here is a brief of what we do. We provide next-gen IT services with a very clear focus on data engineering. In data engineering, if you look inside, it's largely big data, both on cloud or on-prem. And on the big data engineering, we provide consulting, recommendations, solution design, architecture for building the data platforms, as well as implementation of robust data lakes and warehouses. Another super eminent area of focus is cloud engineering. We began working on cloud in 2010, and now most of our new big data engineering work is largely on the cloud. We are known to have built complex data engineering infrastructure on the cloud for some of the largest enterprises. And our customer really find us head and shoulders above our competition. Again, under cloud engineering, we are providing end-to-end services ranging from designing, architecting, these data platforms, building the platforms and applications on the cloud. And these applications also include various applications, AI and ML applications. We also provide specialized services around capacity planning, cloud cost optimization, including services for ML and AI applications and cloud DevOps. Now, apart from providing services through several teams of expert professionals, we are also enabling success to our customers through products and solutions we have developed. So again, in the context of data engineering and cloud migration, I'll talk about 3 key Impetus products, as you can see in the slide right in front of you. Leap Logic is one of the product, and it is one of the leading products in the market today. We have used this product in several enterprise environments for the transformation of legacy data warehouses, ETL, analytic systems to cloud. And our product technology removes up to 95% of the manual work, which means more automated migrations and modernization of the enterprises. And these automated conversions and mitigated risks means faster, less expensive transformation for the enterprises, and giving these enterprises much better, faster time to market and overall return on investment. Another product is Gather, and it is known as one platform for all the data integration and engineering needs of the enterprises. So this is a platform which is very easy to use, provides self-service interfaces. You can build, deploy, manage all kind of data pipelines effortlessly. You can ingest data from any source, perform complex transformation, and write the data to any target. The other product that I want to talk, which gels pretty well with the other two products that I just talked about, is Kairos, and it's a platform for the business insight generation. So using Kairos, thousands of users can analyze data, very large set of data with billions of rows in a very fast manner. It works pretty well with all the tools and technologies of any enterprise modern data ecosystem. So in order to serve our customer well, we have partner with our customers to help them achieve their cloud data goals. And in order to bring the partnership of this level, we collaborate with several organizations from diverse industries to help advance their digital engineering needs and ensuring that they are prepared for their future needs. So these are some of the industry types that we are working with. It does not represent the complete Impetus portfolio, but just a quick view onto what kind of industries our clients are from. And here are some of our partner relationships. We have very mature and strategic positioning at Databricks and AWS, as well as strong partnership with Microsoft, GCP, Snowflake, and others. We have created a lot of trust with Databricks, and we have helped them drive migration in migrating number of deals, basically. And just to put this really super exciting partnership in perspective, recently Databricks won a major business deal this year with a multi-year commit from their customer, and they attributed this biggest win of the year to Impetus. Here are some of our enterprise customers that we are working with. Very short while ago, I talked about various types of industry, and here you can see a mix of organizations from financial services, healthcare, telecom, retail. So all sort of organizations that we are working with. Our forte is primarily data engineering at scale in the cloud, and with this strength, we attract customers from all kind of domains that we have, whoever have complex data engineering needs. We have also partnered with the global Fortune 100 companies to support their data initiatives and help them accelerate into a modern digital future. So as you can see here, we have, our products and solutions have received multiple recognition from some of the top global research organizations who are known for providing emerging trends. So Gartner's, Datanomic, Forrester, you can see all of these people recognize the Impetus products and the contribution Impetus is making, the impact Impetus is making in the industry. At Impetus, we maintain a very healthy environment and make every one of our employees feel that each of them belong to a team and they're not entirely on their own. People are made fully aware of the big picture, about organization and customer. Our objective is to make sure that every individual in the organization is given the opportunity to learn and grow their skills. Our processes and policies are people-centric. People are encouraged to reach out in case they get stuck. And these initiatives are very well appreciated by our people, and it has brought us several recognition for several years in the row now. So you can see, the industry recognition about being the best employer, a dream company, best place to work in tech, from various well-recognized research and research companies. So guys, this is what I wanted to cover, and now I'll hand it over back to Vanshika for driving deep dive into the other interesting topics. Over to you, Vanshika.
Thank you, Prashant. So, welcoming our next speaker, we have Mr. Aditya Parasurampuriya. Aditya is a solution architect with experience in system design. His area of focus includes cloud computing, data engineering, containerized and serverless architectures. Aditya is also involved in multiple client assignments as well as internal product IPs. So Aditya will be taking up the session on rapidly build secure serverless microservices. So can we have you, Aditya, please?
Thanks, Vanshika. So, hello everyone. I hope all of you are doing well. Today we'll be talking about how we can actually build modern microservices rapidly using a serverless approach. So before we delve into the approach itself, we'll be talking about what actually are microservices, because it's a popular design pattern which is being followed across enterprises for complex application development. So basically, if we talk about microservices, these are architectural style and organizational approach to software development, right? And in which the application is essentially structured as a collection of services, each solving a particular set of functionality and catering to a particular business requirement, right? So while doing this, we have to ensure that the services should be highly maintainable and testable. They are loosely coupled. They are independently deployable, and they are organized around business capabilities. So basically, different functions or the domain of the application should be candidates for different microservices. And also they can be owned by a small team. So you don't need to have a large team, because it's not a monolith. It's divided into pieces. People of different, technology expertise can own different pieces of the microservices. While we talk about that, developing microservices and maintaining them could also, entail a lot of additional overheads, and we'll be talking about as we proceed further. And we'll be talking to the course of this session how we can, minimize those overheads by opting for a serverless approach that can actually reduce our time to market, improve scalability and response times as well. And before we dive into that, so let's talk about the serverless architecture. So it's essentially a way to build and run applications without having to manage infrastructure. So it's not as if you don't have servers. It's more of like the server management is done by your cloud provider, right? It could be AWS, GCP, Azure, or any public cloud provider for that matter. What it allows you to do is basically help you focus on the product, because all you need to do is just focus on the pieces of code functionality and not associate yourself with the infrastructure management and the operational overheads. The overheads like maintaining server hardware, software and security updates, management, taking care of backups and versioning and all that stuff. So that's basically taken out of the equation, right? So another important piece to note about the serverless architecture is that it's purely driven through event-based architecture, right? So whenever you get an event, it could be an HTTP event or an API event. It could be some asynchronous event, whatever it is. Your application or your function code responds to that particular event. So therefore, you don't have to provision resources upfront. It is basically invoked at the time of event trigger. So you must have come across many of those popular serverless services, of which the most popular paradigm is FaaS, as we popularly call it, which is function as a service, which includes services like Lambda, Azure Functions, Google Cloud Functions. But then there are other services which are also there in the space of containerization, which makes use of serverless as well, right? To name a few, it could be something like like ECS Fargate or AWS App Runner for AWS. Then there could be container instances for Azure, or there could be like a Cloud Run for GCP. Similarly, the scope of serverless doesn't restrict itself to compute. It is spread across databases like Aurora Serverless, DynamoDB, or something like a Neptune DB in AWS, and in Azure you could have Cosmos DB, and the list goes on. In storage, you could have services like S3 and blob storage and other services. For application integration, you could have services like SNS, SQS, and the likes, right? So basically, the entire breadth of services in serverless is very widespread these days, and not just limited to function as a service, as it is popularly known as. So coming to how we can actually leverage serverless to build microservices rapidly. So essentially, I mean, when we talk about serverless services, we can actually think of cloud-based services that leverages serverless functions to perform highly specific roles within an application. Okay, so here the focus is writing only the business logic and not on the other aspects of the deployment, like infrastructure management, the scalability, request routing, API gateway management and all that stuff. You just focus on your business logic by writing the function code, and you have got tools at your disposal that can take care of the rest of the pieces. Uh, to also add to that, there are services in serverless API space, which acts as a gateway that you can use leverage to act as a front door for your incoming request. So basically, you can have serverless API gateways as well in multiple cloud providers, which can act as your front door for service consumption. And the segments of code are executed in serverless functions in response to HTTP events, right? But like I said, not only HTTP events, you could have something like functions getting executed in response to queues, to asynchronous fan out architectures, or any kind of events you could have to get your code executed. So what ensures that you can basically scale your microservices as per demand? So essentially, there's a concept called function concurrency, which is supported out of the box by most of the leading cloud providers. And what it essentially does is it gives you the power to provide the number of parallel requests your application can handle. So basically, since your code will actually interact with multiple services downstream, it could be databases, it could be some other services. So based on the bandwidth you have on these downstream services, you can actually define the number of parallel requests your function can actually ingest. And that in turn will determine how you will handle the requests if they exceed a particular threshold. So you could design your custom events to decide if you want to throw a particular throttling errors in case the request goes beyond a particular limit to prevent scenarios such as the DDoS attacks or something like that. So here, when we talk of the microservices, they entail a lot of advantages, right? I mean, first of all, being most important, that is low cost, because your function just executes in response to the events. Okay, so therefore it is highly cost effective. Then it is basically a highly scalable system, right? Because like I said, you can define the concurrency to drive what kind of traffic your application can cater to. Okay, and also like another advantage is that the core tenets of microservices like routing, protocol translation, service discovery, they're all supported out of the box. You don't have to put in additional efforts to support them. And also they support modern standards like HTTP version 1.1, version 2, gRPC, WebSockets, and different kind of transport layer protocols. Also, optimization techniques for low latency can also be achieved using CDN. So you can pair up things like something like a CloudFront or any other CDN, so as to reduce the latency of your API response times when you want to cater to a global audience, like when you have a distributed audience spread across different geographies. So you can make use of CDNs to reduce the response time of your microservices APIs. And they also ensure faster deployments, because what happens is whenever you deploy a version of the code, the latest version of the code gets deployed almost instantaneously. So practically speaking, you have almost zero downtime in your applications, and the deployments, because they only deal with a particular piece of code bundled together, hence the deployments are faster. So therefore, you can iterate faster, and you can reduce the time to market as well. Now, here in this slide, we have actually tried to capture a different aspects of the microservice development and how do they stack up against the various offerings in the cloud, right? So basically, towards the left, we see various aspects of microservices or various components of microservices, and the ones that the services which can actually be leveraged to achieve that. So, for example, you can make use of API gateway, like services like AWS API Gateway, Azure API Management, or Google API Management can help you achieve the API gateway for handling the business layer or the business logic. You have things like Lambda, Azure Functions, and Google Cloud Functions, which basically constitute the fast part of it. If you want to handle identity management in a serverless fashion, you have got a lot of again offerings in the fray, which includes AWS Cognito, Active Directory from Azure, Firebase, Google Identity Platform, Auth0, Okta, and these are just to name a few. You have got a plenty of other options which can pair up easily with your serverless microservices without having to do any heavy lifting for your identity management. And with regards to the service discovery, again, you can make use of the API services to ensure service discovery in case you have got a large number of microservices and you want coordination between them. When it comes to databases, although I did give a glimpse of a few services a while back, services like Aurora Serverless, DynamoDB, Cosmos DB, and MongoDB Atlas Serverless, to name a few, are the ones that you can use to construct serverless applications and use a serverless database. And for content acceleration, that is to reduce the latency and response times of your APIs, you can make use of CDN solutions like CloudFront, Azure CDN, Google Cloud CDN, and the likes. Now, when we talk of security, it's also important to make sure that we filter out kind of a malicious traffic that comes in, or any kind of malicious request that comes in before it actually reaches the business layer, right? So in such cases, we can make use of services like AWS Web Application Firewall, or Google Cloud Armor, or Azure WAF, which basically contains pre-built or custom rule set which you can apply to incoming traffic to screen out malicious IP ranges or any kind of abnormal traffic patterns, anything of that sort. So basically, using a combination of all this, you can design a secure environment for your microservices, which is highly scalable and faster to achieve as well. And in this part, so we'll be quickly going through one of the use case that we achieved for one of our clients, wherein they wanted to move away from a legacy architecture which was splintered across different applications, all developed using monolith architecture. So we helped design serverless architecture for them and leveraging serverless services as much as we could. So basically, Cognito acted as our identity system. CloudFront was our CDN. Content hosting for the web applications for React and Angular, which they had, was done using S3 static hosting. And API Gateway and Lambda acted, or this pair acted as a front door for us to expose our microservices. So we had numerous microservices. I just illustrated a couple of them for the sake of simplicity and clarity. So any number of microservices, we could actually build upon it and have the Cognito secure the access to this, not only by ensuring authentication security, but also managing the authorization to the various endpoints of the application. And then we had this Aurora Serverless as the database backend, which provides fully capable MySQL and Postgres backend. In our use case, we leveraged MySQL for our use case. So Aurora Serverless helped us scale immensely from a very low user base almost instantaneously. And then there were other layers of application that paired it up with includes KMS, Secrets Manager, and IAM. And for management stuff like CloudWatch, X-Ray, and Terraform and Serverless for IAC, and services like SNS and SES for notification and email management. So yeah, I mean that's about it from how did we achieve serverless microservices at scale. Any questions?
Yes, we have questions on board. First one is, how scalable are microservices on serverless architectures?
So like I said earlier, so like it's a highly scalable approach here. So like if I were to give an example, by default in AWS, like there is a concurrency at account level provided as 1,000, right? However, it's highly configurable, and in our many use cases, we have actually cranked it up to 10,000 requests. So right, so if you have got a database backend that responds well, you can practically handle thousands of requests per second, which actually, if you have an evenly distributed traffic, you can actually cater to hundreds of thousands or even millions of requests in a day. So it's highly scalable in that aspect.
Okay. So next question we have, can I secure serverless microservices using enterprise SSO? If yes, how?
Yeah, so enterprise SSO, like again, is a very common use case with enterprises, and like I said, there are a plethora of identity management solutions out there, which you can actually make. You can pair it up with your SSO solutions. Like it could be Active Directory or any other Okta or any other solution you want to make use of. You can simply pair it up with serverless solutions like Cognito or Azure Active Directory, and you can. They have got built-in support for SAML integrations as well, which basically is the bedrock for most of these SSO implementations, right? So having SAML support ensures that you can basically integrate any type of SSO, enterprise SSO with your microservices.
All right. Thank you so much, Aditya. Now, next up, we have Mr. Ayush Jain. Ayush is a solution architect with 11 plus years of experience in design, developing, and deploying scalable cloud architectures. He has proficiency in cloud migration, building end-to-end ETL pipelines, data management, and cost optimization. So today, Ayush will be taking up the session on cloud architecture maturity assessment. So over to you, Ayush.
Thanks, Vanshika. Hey, everyone. I will be briefly talking about cloud architecture maturity assessment, or KAMA framework, which we have built from our vast experience helping organizations migrate and build well-architected framework on cloud. So as more and more organizations are trying to onboard their journey to cloud, so it becomes very important to understand that just moving to cloud is not enough. While cloud gives a lot of flexibility and saves efforts, the main aim is to make the right choice available uh, with whatever services and options that we have, and to build a secure, scalable, and optimized cloud architecture. So after working with so many customers, we kept on asking to ourselves, so what is a gold standard defined over here? How do we define that our architecture that we have built on cloud is mature enough? So that is where we get started with the KAMA framework. And to simply put, we can say KAMA is a framework which examines your current state of architecture on cloud, identify gaps with existing processes, and then recommend solutions to fix those gaps and help to implement the same. So it is not just the problem with the new customers who are trying to onboard their journey to cloud. Also with existing customers, say who have been stable, say 1 or 2 years down the line, they start observing that spikes in their bills, and they start looking for options to switch to another cloud or say hybrid strategy or multi-cloud. So the reason is that the initial estimate that they had about the cost was much lower and was according to the ideal situation that they might have thought. So, but in reality, when you come across different pipelines, different environments, your cost seems to grow. So here comes KAMA. KAMA analyzes your spending behavior and recommends solution to build efficient and cost optimized systems. The other feature of KAMA is that it is not cloud agnostic. So it is cloud agnostic. That doesn't depend on any specific cloud, AWS, GCP, or Azure, and it supports both hybrid and multi-cloud as well. And this is not something that we have defined as the best practices for the cloud architecture, but this is something that we have gained working with Fortune 500 customers and our advanced partnership with AWS, Azure, and GCP. So it is pretty much handcrafted for a specific project and not something pretty generic content you have available on the internet. So now let us understand like how do we define a well architected architecture on cloud. So these are the 5 foundational pillars to any cloud architecture. So operational excellence focuses on running and monitoring systems and continually improving processes and procedures. Key topics over here would be automating changes, responding to events, and defining standards to manage your daily operations. The security pillar, as the name suggests, focuses more on protecting information and systems. Uh, it is not limited to just your security groups or firewalls, but it also means getting in compliant with your security restrictions depending on the region and the country where your infrastructure lies. The reliability pillar mainly focuses how quickly your system can recover from failure to meet business objectives like RTO and RPO, which can vary from system to system. So it mainly will talk about distributed system design, recovery planning, and trying to adapt to changing requirements. Talking in terms of performance efficiency, so we can say a system is performance efficient when it can select the right resource type and size optimized for workload requirements. So it doesn't only means that selecting type of instances and of which size, but also helping you decide that should you go with the serverless option, should you go with your own provision clusters, which one would be more performance efficient to you, which one would be more cost optimized. So depending on the needs, suggesting the right approach. And last of all, the cost optimization pillar, it works pretty much well with all of the pillars, and it's common in all of the planning and processes. So it focuses on avoiding unnecessary cost. Key topics would include fund allocation, implementing a chargeback model, identifying and terminating unused resources. So probably you would be asking questions like, are there some zombie assets lying in some environment somewhere? Or is there a pile of backup snapshot lying somewhere? Or are there some underutilized instances which cannot be viewed from naked eyes or from a human eyes? So it tracks all of these things and then recommends solutions to make your system cost optimized. So now let us understand how does this framework actually work. So first of all, we engage with the organization to understand their existing architecture on cloud, their business priorities, pain areas, and security concerns. We then examine their current processes through a set of questionnaire for each foundational pillars that we discussed in a pretty objective fashion, and then evaluate the current state on the basis of responses that we received. So the evaluation process is not generic, and it takes into account only the things which are meaningful to your particular organization. So one of the project might be dealing with microservices, other mainly heavily involved in data pipelines. So the questions and the responses are evaluated on the basis of things which are meaningful to that architecture. So after the evaluation, we try to identify the gaps and then recommend solutions and help them move to the next level. We'll talk in details about the different levels. So every organization doesn't need to go through the entire process and can work to choose with any of the specific pillar to get started with. It could be like a cost optimization. It could be trying to meet your compliance and security checks. It could be trying to make your system performance efficient. Yeah. So now let's talk about different maturity levels that we have been seeing. So to simplify, we have defined like categorized into basic, intermediate, and advanced level. So basic can be the one who has just recently moved to cloud, say like just perform lift and shift and no automation or base practices in place. Okay, intermediate could be the one who is on cloud for some time and maybe partially following some of the processes, but say still hasn't cracked the code for a fully optimized architecture. Advanced, or the ideal state that we are calling, is that where you have all the base practices in place for different services, for fully automated processes, and trying to make the best use of every penny that you spent on cloud. So Karma tries to identify and understand your current state of the project and guides them to transit to the advanced or the ideal level. Well, let us talk about some of the use cases that or the organization that we have worked with. So we have worked with a business intelligence product where we try to save their cost up to 30%. And then we have also worked with insurance provider in US for which were only meant for operational process automation. How could we make their processes better, and setting up different environments with a single click. Other examples would be the same, like cost optimization for other clients for financial domain, and dealing with compliance and security checks. The gist of these pieces, we are trying to build up that you don't need to focus on each and everything. So probably you might be good with your security restrictions or compliance, and can focus on the cost optimization pillar itself. So I'll just try to conclude over here, and I'm happy to take if you have any questions over here.
Yes, we have questions. So first one is this tool cloud specific? Does it give cloud specific recommendations?
Yeah, I'll answer in two parts. So it is not cloud specific, I would say, but it does give cloud specific recommendation, so that your project could be hosted on one cloud or multi-cloud or hybrid cloud. But depending on the infrastructure where it is hosted, it will give you recommendations accordingly. So recommendation will not be pretty generic. It will be specific to the cloud or the infrastructure or the platform where your infrastructure is hosted.
Okay, so we have another question. Is this tool available as software as a service? How long does it take to generate the reports?
Yes, that is in our roadmap. So currently we take about 2 to 3 business days to actually generate the reports, because it's a long process of engagement, examination and evaluation, and then recommending the solution. So it takes about 2 to 3 business days, and we are trying to keep it very much we can say very much akin to the requirements of the customer and not make it very generic. So that is the reason it takes about 2 to 3 days to submit the report.
Okay, so thank you so much, Ayush. Now I would like to call Ms. Rutali Joshi. Rutali is working as a lead software engineer with Impetus Technologies. She is having 10 plus years of industry experience of designing and implementing high-performance data pipelines and data warehouse solutions. She also have an expertise in architecting, planning, and migration of projects from on-prem to cloud. She worked on implementation of robust and secured cloud solution adhering to compliances and country regulations in banking and finance industry. So Rutali will be taking up the session on Data Platform Accelerator. On to you, Rutali.
Yeah, thanks, Vanshika. Hello all, and thanks for joining. So before we dive deep into what Data Platform Accelerator is and how and where it can be used, let me set some context with a real life use case. Okay, so imagine a customer who has approached Impetus and they are saying that they are not having any infrastructure on cloud at the moment, and they are not even having any cloud expertise within their organization. But still, they want to move their on-premises data and the applications onto cloud. And they do not want this process to be very lengthy, like a couple of years, which usually happens during these long migrations. They basically want to leverage the benefits of cloud pretty quickly, and I mean, reap the benefits or gain their business values. So what is the answer from Impetus? So the answer from Impetus would be Data Platform Accelerator. So what Data Platform Accelerator provides? So basically, as I said, it is a fast track approach to set up your data platform on cloud. So when we say fast track, it is basically, I mean, it reduces the efforts from months to few weeks. We still need to do some prerequisites. We still need to analyze the customer data and other business requirements. But yeah, it significantly reduces the time required to set up or migrate the data and leverage the data related benefits on cloud. Now, when we talk about data, the very important aspect is moving or migrating that data onto cloud. So Data Platform Accelerator provides capabilities to ingress your data from diverse data sources into cloud through a set of selection rules. So you can decide in which phases you want to move your data, be it full load, be it ongoing replication. You can select selective tables, you can apply filters on top of your data, and you can decide how and when you want to migrate your data. Now it provides a single easy to use UI and a dashboard to manage your existing data platforms or create new data platforms. So talking about Data Platform Accelerator capabilities, basically this UI will provide you options to create a very new, entirely new data platform by migrating your data and leveraging data related benefits. Now imagine that you have two teams, one is development and one is testing, and you need to create two similar data platforms for them. So you have an option to clone your existing data platform. Similarly, when you do not need any particular data platform for any needs, you can just delete it with single click, and it will delete all the cloud related resources, and it will stop the cloud billing for those. Similarly, this management dashboard will provide you options to add or auto scale your scale your analytical clusters as per your business needs. And it will also provide you options to hydrate your data platform once it is spun up. I mean, it is not necessary to migrate your data in one go. You will get option to fill up a form afterwards to ingress your remaining data or the new data into data platform. And the last value addition is it is a single platform to meet all your data related needs. So be it data governance, data security, data cleansing, data cataloging, you will get options to do anything and everything using Data Platform Accelerator. Now quickly touching upon key benefits of DPA. So basically it is a scalable and rapid implementation with minimal configuration. And when we say that, when you try to create an entirely new data platform, you will just be asked some basic information on a series of stepper forms, like 7 to 8 stepper forms on UI. And with a single click, you will be able to spin up your networks, your compute resources, your storage. So you need not to have any separate knowledge, or you need not to integrate different cloud specific services to have this kind of infrastructure. Now, second one is unified interface for data access and policy management. So obviously, since we are on cloud, we are following a principle of least privileges. So this platform gives you option to secure or protect your data from malicious users. And intelligent storage tiering for cost optimization. So obviously, I mean, since we are on cloud, basically we can move through different layers to just store the data that you need, or which is going to give the values to your business. Okay, now I'll be covering one sample use case, and with that I'll be explaining all the features of this particular accelerator. So imagine a banking customer who is having two database engines on premises. One is MySQL and one is PostgreSQL. And for the sake of simplicity, we are considering that that customer wants to migrate 5 tables, 5 full load tables into a data platform using Data Platform Accelerator. So what will Data Platform Accelerator provide? So as I said, it will provide a one-click setup for your network, storage, and compute resources. Secondly, it will provide you options to migrate your data onto cloud. So you can choose between different options like full load, CDC, or real time for that matter. After that, you can curate your data as per your business needs, and the cleansed data will be stored in separate buckets apart from your raw data. Also, you can secure your data using tag-based access policies, role-based access policies, and you can even mask your sensitive data or personally identifiable information. You can catalog your data for faster access. You can have a data lineage which will show basically journey of your data since the time it entered into Data Platform Accelerator till you curated it and gained business values out of that data. And also it will provide an option to move your cleansed data into different data warehousing tools, and you can even run your analytical jobs on cleansed data, and you can point your BI or reporting tools so that you can get visuals out of that data. Okay, now talking about data flow within Data Platform Accelerator. So the very leftmost side shows your source data. So it will be your on-premises or customers on-premises, and it could be in the form of relational databases or NoSQL databases. It could even be your IoT or sensor data or flat files. So be it any kind of data, any diverse data sources, Data Platform Accelerator will be able to move that data into the cloud buckets. So the very first bucket that the data will land into after entering into cloud will be the raw bucket, and it will be a single source of truth of whatever you have migrated into cloud. Then from this stage, automated event-driven pipelines will run, and the raw data will then be moved to submission layer, which will then act as a base to cleanse or catalog your data or apply any data related policies on top of it. So after cleansing, the data will be moved to curated layer, and that will act as a base to point your analytical jobs or run your machine learning algorithms, and then point the visualization tools on top of your analytical results. Similarly, you can move your curated data into data warehouse too, as I explained earlier. Okay, so most of these features are already covered by me while explaining the use case. I'll just quickly check if anything is missed. So we have already covered infrastructure setup, data hydration. I mean, you can decide the frequency, you can hydrate the data platform on ongoing basis as well if you get any more new tables on your on-premise databases. You can curate, catalog, and secure your data. Data lineage we have already covered, and the support for data warehousing, data analytics, and visualization is also covered. Now, coming to prerequisites. So initially I said that Data Platform Accelerator will reduce the efforts of data platform creation from months to few weeks. So why do we need those few weeks for? So basically every customer has different needs. They could be having different kind of data sources and different migration requirements. And they may want to leverage different features provided by this accelerator. So there are some basic setups that we perform before, before we can leverage the front ends or management dashboards provided by this accelerator. So what these weeks will be used for? So first of all, we would be setting up a VPN tunnel between customers' network and the cloud network so as to establish a secure connection between the two, and so that the customer can easily and securely access the features provided by Data Platform Accelerator. The second would be the LDAP integration for user authentication. The third would be network policies. So there would be firewall rules set up so that we can blacklist or whitelist the IPs. We can just restrict the access to particular ports or particular IP ranges, etc. Then since we are on cloud and since we are following the principle of least privileges, we need to set up some IAM roles and policies so that we will be able to provide the access only to intended users, and we will be able to restrict what they can do with the existing services. Now, if we are dealing with customers on-premise databases, obviously we do not want to expose the credentials openly to public, or we do not want to integrate those credentials into code. So we would be storing those credentials into secret manager. Similarly, since the data at rest and in transit is encrypted all the time during data platform accelerator journey, we need to create that encryption key and store that securely in KMS. And then there would be some setups regarding the buckets, wherein we would be storing some of the libraries which will be used during data platform creation. And also, I mean, if customer is having any specific requirements regarding their data cleansing, either they can provide their cleansing scripts, which will be uploaded upfront into S3 buckets, or Impetus DPA team can help customer write those cleansing scripts and upload those into S3 buckets before we spin up the data. Okay, now we did a quick comparison of this accelerator with some of the leading market offerings, and one such big market offering is AWS Lake Formation. So I'm happy to share that there are quite a few features in which Data Platform Accelerator is basically better than AWS Lake Formation. So if we see first 5 features, basically those are kind of leaders for DPA. So data lineage is something which is supported by DPA but is not available in Lake Formation. Similarly, a Data Platform Accelerator provides a support to set up entire network in one click without requiring any specific networking knowledge, which is kind of absent in Lake Formation. The multi-cluster support is in beta version in Lake Formation by AWS, but is available in Data Platform Accelerator. And the additional data platform operations like cloning, termination, etc. are available in DPA. Now, if we see point number 6 to 12, they are kind of equal in both DPA as well as AWS Lake Formation. So I'm not going to cover those because they are already covered in features. And there are a couple of features in which DPA is still a work in progress as compared to AWS Lake Formation. So basically, we are currently working on monitoring and logging and alert or alarm setup when, I mean, basically we are breaching any billing related thresholds and all. So it is a little bit matured in Lake Formation as compared to Data Platform Accelerator. But as I said, this is work in progress in DPA. So that's pretty much I had to cover. Thank you all for patiently listening, and I'm open for any questions.
Okay, so first question we have on board is to bring CDC data, the CDC setting must be enabled on premises system. Does DPA take care of that?
Okay, so yeah, definitely we need to do some config changes in on-premise databases. So there are two options. Either customer can take care of those changes by themselves, or Impetus DPA team can help customer identify those changes, and then customer can do those in their on-premise databases to support the ongoing replication.
And next one is what all BI tools are supported or can be integrated with DPA?
Okay, so currently we are having support for Amazon QuickSight, but yeah, I mean, if a customer is having any specific requirement, we can definitely do some analysis, and during that prerequisite phase, we will try to integrate that into the accelerator so that a customer can leverage benefits of the tool of their choice.
Okay, thank you so much, Ratali. So next up we have Mr. Ravi Kelotra. Ravi is working as senior lead DevOps engineer in Impetus and have almost 15 years of industry experience and have been working with Impetus from last 12 years. In terms of expertise, he is having a good knowledge on Java J2EE automation, setting up CI/CD process, designing and implementing solutions on clouds, performance engineering, and DevOps tools and technologies. So today, Ravi will be taking up the session on DevOps cloud enablers. So can we have you, Ravi, please?
Sure. Thanks, Vanshika, and thanks everyone for joining us today. So, in this particular sections, we are going to talk about what is DevOps and as impetus, what are the different DevOps offering we have. And then we will see, right, how our different enablers and accelerators are helping our customers to expedite their cloud journeys. So, let's quickly talk about what is DevOps. So, DevOps is basically a combination of two terms, development and operation, where both the teams work in collaborations to make an automated software deployment in repeatable ways. So if you see the middle sections of the slide, right, as a DevOps offering, we have the infrastructure management, we have platform management, and we have the application supports. So to deploy any application or software, first thing is we need the infrastructure, and that's where we are supporting our customers. And in infra management, we are like helping to set up the infrastructure for any kind for deploying any kind of application, setting up the networking and securities. And along with that, we are also like continuously monitoring this infrastructure to get the current capacity and the future capacity need for any infrastructure. Once we have this infrastructure, on top of that, we build the platform. So let's try to relate it with the big data technologies. So let's suppose we have the commodity hardwares. On top of that, we build the platform, like the Hadoop platform, right, for setting up our big data clusters. So once we set up this platform, we are responsible definitely for setting up the platform as well. But once we set up this platform, we are also managing and administrating these platforms where we are like making sure like different departments from different team is getting the right resources from these clusters. They are like accessing the data that they belongs to their department and not the others. Making sure the securities and monitoring are in place so that if any case any incident happens on the platform side, we can address those issues on in time. So once we have this platform set up, right, on top of that, we deploy the application. So in big data terms, it can be an ETL application, right, where this ETL logics or ETL application is like processing the large amount of data to get the meaningful insights out of that data. And this ETL is basically a business logic and it keeps changing, right? So we have the continuous integration and deployment and delivery setups through which we will be like upgrading all these ETL logics to different environments. And we make sure, right, whenever we are doing this deployment, our customers are intact, right? We are not having any downtime. So for that, we have the different deployment strategies. It can be like a blue-green deployment. It can be a rolling update with additional patches, just to make sure, right, the any deployment on the business side will have minimal or almost no impact on the customer business. And just like this ETL is nothing like that we are deploying into the production, right? It goes through a different environments from development to QA to stage to production. So we make sure, right, in a single click deployment, via some approval process, we are able to deploy or migrate this logics or this application from one environment to another, where we again use tools like Jenkins, TeamCity, Bamboos for implementing the entire CI/CD cycles. Uh, we also like offer on containerizations where we are like providing the support for Kubernetes platforms to deploy the applications. And once this application has been deployed, we make sure like we are monitoring this application and not just application, the platform and infrastructure as well, so that any issues or any incident that happens into any of the environment, especially like the critical environment production or stage, we are responding to those incidents and change requests within a given SLA. So we have different SLAs based on the different environments, and we are bound to respond to those incidents within a given SLAs. And in a large organization, based on our experience, what we have seen is like there are various teams, right? Those are teams deploying different applications across different environments and platforms. So we intend to build the operational dashboard where we can like see all these different departments or the application from different departments into a single operational dashboard so that we can act accordingly and we can act on those alerts and incident within a given SLA. Now to roll out all those things, right? We follow the agile process. So we have the scrums and Kanban in the place so that we can collect the matrices or around the incident and change request just to make sure, right, we are not escaping any critical incidents or missing any critical incidents within a given SLA. So we follow the Scrum and Agiles around that. So that is all about our DevOps offering. Now let's see right in our next slides how different offerings we have on the cloud side. So if you'll see in this slide, we have four different dimensions where we are providing or offering on the cloud DevOps. We have, if you'll see the top left, right, we have the cloud operations, where we are responsible for managing the infrastructure, platforms, applications. Also, we are responsible for any incident that is happening or coming on the cloud. Uh, any instance patching or any particular operating system upgradations, that is also be considered as a part of cloud operations. Then we have, if you see the top right, we have the continuous innovations where we are like providing the automation to our clients. It can be like in the form of automation script. It can be an infrastructure automation where we are writing the template in the cloud formation or Terraform to provide or to spin up this infrastructure to deploy the applications. We are also like helping them to set up their CI/CD process to deploy any application on the cloud. uh, we are collecting this data from different I would say logs, just to provide and predict the and forecasting of the resource requirement as well as the operational requirements. Now, if you'll see the left bottom, right, we are providing support on the security side as well, where we as a DevOps, we are responsible for managing the network, infra, platform securities or application level securities that we are like leveraging with the help of user management and access controls, firewalls, and whenever any prospect moves the his infrastructure from the on-premise to cloud, right, application security and data security is their concern, right? So we are helping them to provide encryption for their data, and that encryption can be in transit or in rest. Uh, we are using the I would say the native tools provided by different cloud providers or external tools for providing these encryptions, and we are proactively keep monitoring their infrastructure, right, for any kind of uh, anomaly detections, right. And if you'll see the top right sections, where we are responsible for optimizing the cost, mostly the prospect are trying to move to the cloud just for the cost factors, right, and if it is not worthy, then they may change their decisions, right. So we are responsible for optimizing their cost. Time to time, we basically, like as I shared, right, we are assessing their cost, we are analyzing it, and we are trying to optimize it down over the time. For example, for that, we are doing the resource tagging. We are tagging the resources based on the different departments environment, so that the large organization can charge back those departments based on the utilization. We are making sure that we have proper setup on the alerting on the budgets. If any of the team is exceeding a particular budget, we are getting the alert notification, continuously monitoring their resources so that we can optimize. Uh, Another aspect of cost optimization can be data archival. So various cloud providers like charge the storage based on the different storage classes. So we encourage our clients or prospect to move the less frequent access data to a different storage classes to reduce their charges on the cloud side. So that is all about our cloud DevOps offering. Now let's see, right, as impetus, what are the different enablers and accelerators that we have that can expedite their cloud journeys. So as impetus, right, we are continuously assess their DevOps process. We always apply the best practices and recommendations. So these are the different enablers, right, that is really helping our customer to expedite their cloud journeys. So if I talk about, we have the Terraform built-in modules that can with that and it is this modules for like for different use cases. We have different modules that can really help our customer to automate their cloud infrastructure, and the customer can set up their infrastructure 30 times faster than their manual way or actual way of doing or the regular way of doing. Similarly, we have the cloud security monitoring, through which we can quickly analyze any of the cloud environment to make sure, right, whether their cloud environment is compliant to a particular standard or not. We have the Cloud Cost Explorer, where we can check the cost for various cloud providers, and that can be segregated to various accounts level. Then we have DevOps 360. It is a single unified view where we can analyze the data from different needs and from the different clouds, and it can also like analyze the data from the on-premise as well. Then we have the Kubernetes automations. This is the one of the automation script that can reduce your cluster setup by 30%. And all these enablers that we talked about is like working well across all the environments, whether it's AWS, Azure, or GCP. So it's not possible to cover all these enablers in a single session. So we are trying to cover like few of them. So let's see in the next slide, right, how our security, cloud security monitoring is helping our customer. So this cloud security monitoring is basically a real-time monitoring of cloud security compliance. So there is a center of information security benchmark, right? CIS compliance that I would say basically. So with the help of that, we can assess any of the cloud or any of the cloud infrastructure in the environment, whether how secure that environment is. And with the help of this cloud security monitoring tools, we can quickly assess any of the cloud environment and what is their security level as of now. And once we have identified, then we can help our customer to close those gaps, security gaps. And it is a single pane of view for across multiple cloud accounts. So basically, like what we have encountered in a large organizations, there are multiple AWS account or Azure account, right, based on the different departments and all. But as an organization, that is a single, right, single organizations. So with the help of this cloud security monitoring, we can like filter out the data based on the different accounts, just to see right which account is violating how many rules for the CIS compliance. And it can help the organization to smoothly like build one security policies that can be applied across the uh, organization level for all the accounts. And then based on the different accounts need, we can like really we can provide uh, some release on those security rules. Or uh, then the third thing is for last thing is like this security compliance or the framework can help you to even get the details about the resource level. So with the help of this monitoring tools, even you can drill down to a particular resource, like what kind of security violations are there, that can really help you to identify those security vulnerabilities, and can you can close those security vulnerabilities by drilling down into that resource level information. So that is all about our cloud security monitoring. Now let's see in our next section, right, how our DevOps 360 is helping the our customers, right? So DevOps 360, if you'll see in the left side, right, there are in DevOps there is a lot of tools and technologies, right, and it is endless, right? It is keep adding. So with the help of this tray of 360s, you can get a unified view of your uh, infrastructure or platform or application. Usually what we have observed, right, different monitoring tools either provide the infra level monitoring or platform level monitoring or application level monitoring. It is hardly to get a single tool where you can get all this monitoring. And if it is there, then it is the cost is huge. But with the help of the DevOps 360s, with the minimal cost, you can get all this infra platform and application level monitoring. And it is not just for the monitoring purpose, it is like can help you end-to-end tracking of the issues. So the DevOps 360, you can easily integrate with your incident management tool like ServiceNow or Jira, so that if any incidents happen right on any particular tools or services, you can raise an incident and then you can track it from the beginning to the closing in the incident management tool. And you can get the integrated with the other monitoring and alerting tools. So whenever any incident happens, basically you will get an alert. You will work on that alert, and you can close those alerts. So all these things end to end can be monitored on, and can be monitored on the DevOps 360s. So as I said, right, it can be easily integrated with the incident management tool. So with this, you can like get the data from this incident management tool, and you can analyze like how many incidents you are getting in a particular month, and based on that, what is the frequency it is increasing over the time, and then based on that, you can like take a decision whether you have to like increase the uh, team size, or you what are the areas, pain areas that you need to target to reduce those incidents. So it also help you in predicting and forecasting of your DevOps team, right, to take or to act any of the incident. And this particular DevOps 360 tool is not like just uh, uh, bound to cloud. You can even monitor your on-premise environment or cloud and hybrid both in a single phase. And uh, whenever we have this application deployed on cloud, right, it generates a lot of logs files. So this DevOps 360 can help you to analyze those logs and can give you some contextual insight out of those logs to tell you, right, which particular tools you are getting the incidents, which particular service or application is causing more incident. So it can help you to get the contextual insight from this piece of or the log files. So that is all about, I think, DevOps 360s. Now let's move to the next slide and see, right, what is our Kubernetes automations. So setting up any Kubernetes cluster, especially like the production readiness cluster, where you can quickly go and deploy your microservices, takes a lot of time. It can be like 2 or 3 weeks, right? But with the help of this Kubernetes automation, you can reduce this cluster setup time to 3 days. And let's consider an organization where we have a 10 to 12 cluster, right? Different depart based on different departments and teams. So based on our experience, we are saying, right, if you have 10 to 12 clusters, then you can almost reduce those efforts by 500 hours if you are starting using our Kubernetes automation cluster. And as it is automation, right, so it eliminates all the risk that may be there when you are setting up this cluster manually and especially like repeatedly in different environments. So with the help of this automation, as it can be repeated across different environments, across different teams, so overall you can like quickly set up the clusters. As I said, right, it is a product. It set up a production readiness cluster, right? So it has the integrated monitoring tools when you set up the cluster. Along with the cluster, it also set up a monitoring tools through which you can check the health of the cluster or the application that is deployed inside the cluster. And as I said, it is a production readiness, so it follows all the industry best practices and recommendations that are there. So overall, like this Kubernetes automation cluster can really help you to save you a lot of efforts when you are utilizing it across the different environments. So I think that's all about our different enablers that we have, and that's what I wanted to cover today. So I'm open for any session questions.
Okay. So first question I would like to ask, how do you measure the DevOps maturity? Do you guys follow any standard or best practices?
Yeah, right. So, like whenever any prospect comes to us, right, we have our internal assessment that is somewhere related to Dora matrix. So we basically like analyze their environment, assess that environment, and then come up with, right, what are the gaps that are there as part of as Dora standard, right? It should be there. So we assess that and then we try to close those gaps. So we have our internal assessment, but that is somewhere like aligned to Dora matrix. That is the standard that we followed on the DevOps.
Okay. And next one we have how DevOps 360 is different than other monitoring tools. Is it possible to customize the graphs and reports based on different needs?
Okay. So as I said, right, DevOps 360 is a kind of a plug and play. So it has around 100 plus connectors available where using those connectors, you can quickly connect to different tools and technologies to get the data, analyze this data on this DevOps 360 platform. And as we are getting this raw data, right, we are dumping into our own RDS or database system. Definitely, we can like make queries or write our own custom queries to interpret and analyze the data based on our demand. So definitely, we can customize the graphs and report based on our needs as the data is in our database system.
Okay. So thank you so much, Ravi. Now
Thank
I
you.
would like to introduce our next speaker, Mr. Shobhit Tyagi. Shobhit is working with Impetus from last 8 years and is part of data science team. He has total for more than 9 years of industry experience. He had been working upon various technologies such as machine learning, deep learning, natural language processing, machine learning operations, etc. During these years, he worked with various clients like MX, Marsh, UAL, and various internal impetus products. So currently, he's working with Marsh in various ML related projects. Shobit will be taking up the session on AI, ML, and ML ops on cloud. On to you, Shobit.
Yeah, thanks, Manshika. Hello and welcome everyone. So let's talk about AI ML on cloud. Okay. So if you talk about cloud journey with Impetus and ML and MLOps services, so we at Impetus helps the organizations to scale their infrastructures and technology by providing end-to-end cloud-enabled solutions. We have them build an state-of-the-art solutions architectures approaches to implement the solutions. We build custom solutions on top of the cloud. So it's something like if we are working for some client and they have a new requirement, like they want if there is a if the client is some customer care service center and they want to enhance their functionality by providing speech recognition services. So what we are doing, first of all, we are taking the we are integrating API services that are taking care of their voices and verifying that whether that voice of male or female, and also tagging emotions. And then what we are doing, we are converting that speech to text, and then we are applying different analytical and ML models on top of that for doing text analysis and speech analysis. Yeah. Okay, so let's look into some of the data science overview where we had worked on different services and projects. So if we talk about analytical strategies, so we provided SSAI ML read lines, data science lifecycle model management. If we talk about AI ML on cloud, then in this we are doing building deploying AI ML models on containers and virtual machines. We are providing cloud native AI services. In MLOps, we are into model deployment, virtual machine containerization, ML flow, model retraining, and model serving. In AI ops, we are basically classifying intent severity, we are predicting failure, automated monitoring, and so. If we talk about data quality, so in this data quality, we are doing data quality assessment via metrics. We are doing data profiling. We have applications for doing data duplication checks, verifications, and rectifications. In AI and deep learning, we are doing marketing automations, operations automation, and reinforcement learning. Text mining and NLP, we are into identifying topics, summarizing text, classifying sentiments, customer feedback analysis. In image video analytics, we are doing document digitizations, we are extracting text and symbols, we are doing graphic video analysis. For voice analytics, we have built chatbots that includes conversational AI. We are detecting speakers, emotions, managing call center calls. In graph data science, we are doing social network analysis, community detections, knowledge graphs, graph neural nets. In data analytics and modeling, we had done descriptive analytics, predictive analytics, prescriptive analytics. We have done anomaly and fraud detection for various of the banking customers. In energy and utilities, we are doing demand forecasting, reinforcement learning, energy auction bidding. Industrial analytics, we are into object detections using AI. We are doing text extraction using AI. We are doing predictive maintenance. In cybersecurity, we are doing log analytics to patterns, insider threat detections, adversarial threat. In marketing analytics, we had done cross-sells, upsells, lead prioritization, multi-touch attrition. If we talk about cross-sell, upsell, so this is something where we had recommended the customers to, top up their services based on their previous history. So if customer is using some product for a long time, and so we are analyzing their purchasing pattern, and accordingly we are recommending what add-on services he can include in their plan. So these are some of the functional areas where in data science space where we had worked and currently providing our services. So let's look into some AI ML capabilities across different verticals. So we are into advisory, implementation, support, and in this we are providing services into various verticals. So let's see those. In banking, financial services, and insurance, we are doing fraud and compliance, violation detection, personalized offers, property risk model analysis. Supply chain, transportation, logistic, we are doing improved distributions network, estimated time of arrival, inventory management, airline sector. Communications and media sector vertical, we are doing personalized recommendations. We are doing customer journey, marketing analytics, and contextual search. In healthcare and life science, we are doing detect fraud claims, analyzing hospitalization risk, diabetic patient journey, and so other. In manufacturing and automated, we have done lower manufacturing defects, paint shop optimization, IoTs and sensors, failure predictions. retail FMCG, we had done customer journey analytics, marketing, generating recipes with AI, extracting and analyzing the text. For government and law enforcement, we had done application monitoring, suspicious activity identifications, regulatory aspects, and explainability. For smart cities and others, we had done traffic video monitoring, detecting lane changes, traffic density, accidents, sensor logs, and so. So yeah. Okay, so let's look into some of the use cases where we had implemented the MLOps services in the existing ML models. So the first use case is the building height estimator API. So this is we had implemented for one of the insurance company. If we look into the business requirements, the requirement is to analyze building details to process the insurance claim of the company. We need to build an automated process to calculate the building estimates, and estimates includes building height, construction, number of stories. So what is this that initially customer needs to go and verify on the location and check, for whatever request company has asked them to provide the claim for any building. So they need to go send person, and that person they need to do all the analysis by calculating the number of stories, what is the type of that building. So what we did, we had built an automated solution where we will be taking that image of that building through some APIs. And on top of that, we are applying our object detection model. And then that object detection model is trying to creating the set of bounding box. And on the basis of that bounding box, we are calculating the height of the building, what is the construction type of that building. Like if that building is made up of steel, then it's its premium should be high as compared to the wood or glass. And how many number of stories that building is. If building is 3-story or 4-story, or it's a 32-story, then there is a different set of claims that need to be settled for those buildings. And then we are calculating the overall building status to property insurance policies. So let's look into the solution in the next slide. Okay. So for solution highlight, what we are doing, we are fetching the image, as I said earlier. Then we are extracting the building details to generate the building height and construction type of the building. We are identifying the construction categories. So there are 3-4 categories: steel, light metal, tilt up, wood, unknown, etc. Then we are processing the results and sending response using the synchronous and asynchronous call. So this is so user needs to send the address in the form of JSON. And what we are doing, we are taking that address, we are doing all sort of analytics, image analysis, and then we have our own model, and then we are passing that result, that what will be the overall estimate that building needs to be given with respect to the insurance claim. If we talk about benefit, then it will provide a fast processing of building heights estimation requests. So yeah, so this is one of the so this is one of the example, like we have the building, and then we are building a bounding box on that image using our object detection models. And then based on this bounding box, we are trying to identify the different estimates of that building. So this is one of the use case. So let's look into another use case. Okay, so this is another use case where we are building vaccine verification using AWS for one of the significant airline industry. So if we talk about business requirements, so it's a major airline with $1 billion revenue, requires an automated OCR system to extract the information from the vaccine forms. So this is in the time of COVID, where all the airlines had made mandatory for the passengers to carry their COVID form. That on the basis of that, they are allowing the boarding of that passenger. So what we are doing, we are scanning that image of that form, and we are extracting the information on that form, and then we are validating that whether that person has taken COVID vaccine or not, or whether that person is having a COVID or not. And accordingly, we are allowing and that person to onboard the flight. So yeah, so this is what I had mentioned in points also. So passengers are required to submit their vaccine information before boarding the flight, and this is in the form of the uploaded image. So we have the set of uploaded image, and on those uploaded image, we are doing the identifying the pattern. So if you talk about benefits, so solution provides real-time and batch processing. System can be expanded to support visa and other documents. So we are providing supports to visa and other documents also. Okay, so let's talk about some of the recommendation with respect to MLOps. So in cloud platform we provide us different services. If we talk about scalability, so scalability is something in terms of MLOps. So scaling ML application, can be handled. We can handle any amount of data and perform as many computation we want in a cost-effective manner and time-saving way. So that's helped us to scaling down our resources. Explainability. So explainability is something that refers to concept of able to understand the machine learning model. So in order to understand the machine learning model, so we need to do the debugging of the model in the development phase. So this is very important part when we are doing the debugging of the model in case of the development phase. So in MLOps we need to clearly understand the model with respect to the biasness and accordingly do the performance testing by generating various testing scenarios before deploying it into production. For governance, model governance consists of the set of the process and frameworks that helps in deploying the machine learning model. So if we talk about MLOps, then setting up we need to set up an automated pipeline, okay, that reduce the amount of time that has been required to bring the ML models into the production. Then we have the in case of interpretability. So interpretability is something where we trying to build the building the high transparent model. For that we need to understand the exactly why and how that model is doing the prediction. So we need to understand the basic mechanics, how that model is doing the prediction. So for that, in case of MLOps, we need to implement the CI/CD pipeline for model deployment. We need to make sure that we are providing the support to all the required hyperparameters or the weights that are required to train the model and predict the results. Okay. Then we have fairness. So in fairness, in machine learning, fairness of the model is something we are trying to identifying the quality or the state of that model, that whether whether that model is fair or impartial. So yeah, so this is pretty much with respect to the recommendation. Okay, so this is from my side. So I'm open to any question if I have.
Yes. So first question is, what is the skill set required to create solutions on cloud or create AI MLOps platform for digital transformation?
Okay. So in order to create the AI MLOps platform, so we need to have the good data engineering skill. We need to have model building skill. Person should be able to evaluate and validate the model based on the domain knowledge that can help them to build the solution on the cloud.
Okay. And next one we have, how can we reduce timelines using cloud platforms?
Okay. So so cloud platform provide us continuous integration and continuous deployment pipelines that helps us to develop, integrate, and deploy small changes in nearly real-time fashion. It also helps us to readily available all the services that are required for doing data pre-processing, doing expert analysis, doing feature engineering, model development, and model validation. It also provide us services like doing auto ML capabilities, where we need to run all the ML algorithm in one go, and based on the best accuracy our model, we are getting the best model out of the list of 10 or 20 models. So yeah.
Okay. So thank you so much, Shobit. Lastly, I would like to welcome Ms. Nisha Bansal. Nisha is currently working as Module Lead Quality Engineer with Impetus. Nisha is associated with Impetus since last 6.5 years and have worked on multiple domains in her entire career. Her strength is her confidence and courage to accept new challenges. So today, Nisha will be taking us through the topic testing data quality at scale with data quality framework. Can we have you, Nisha, please?
Yeah. Thank you, Vanshika, and hello, everyone. So in the next 10 to 15 minutes, we will be discussing about testing data quality at scale with a data quality framework. Now, we know that everyone is moving to cloud nowadays. So definitely we see some challenges when it comes to data validation, and it becomes important to fight those challenges and have clean and good quality data to mitigate the impact of poor data quality on business. So let's quickly discuss the challenges for any workload migration over cloud. All the data related issues occurs around the 5 C's, from completeness to credibility, as is visible on the slide also. So one is always doubtful whether the data is completely migrated or not. Everyone is worried that they might have lost some data during migration. Correctness of data is again a big concern. Now, because of missing or incorrect information, one has to compromise on downstream decisions as well sometime. Moreover, there is huge cost involved if any data issue occurred during migration, and one has to debug the same on cloud environment. And with each iteration of data processing, a question arises on the data credibility as well. Now, we can't ensure data quality just by validating on these points manually. In fact, we can say it's near to impossible to validate data quality issues manually. On the other hand, these challenges can be mitigated using automation, and today we will be discussing one such solution in the subsequent slides. Now let's have a look on the impact that poor data quality brings upon business. So when the data is of poor quality, one has to spend more time in cleaning and preparing the data, which kills the precious time which one can use in analyzing data and extract some useful information out of it, hence leading to reduced efficiency. And when data quality is compromised, there is a high probability that we can make bad decisions which can largely impact the organization business and credibility. This also leads to huge loss of revenue, and it can be very well seen in the facts as well, where as per Gartner, an average loss of $15 million per year is recorded due to poor data quality. It further leads to increased finances. As we can see, the yearly cost of poor data quality in US alone in 2016 is $3.1 trillion. So we can imagine that if it has to be calculated for all the countries, then how big the amount will be. If the data is not accurate and is not compliant, it can limit business operations too. And last but the most dangerous too, it can harm the company's reputation and can cause loss of customers' trust, and in worst case, we can lose our customer too. Now let's see why we need to use data quality framework. Using data quality framework, one can create validation rules on data to ensure data quality, and we can take informed decisions. Further, to provide more details on kind of data validation, we have bifurcated them into two categories. One is generic data validation and the other is use case specific validation. So let me throw some light on them. Coming to the generic data validations, we have null value checks, duplicate records check, date validations, where one can check the null values in the given data set or the duplicate records in the given data set, and we can check whether the date is in user specified format or not. Coming to the data set comparison, it compares completely the two data sets that are provided, and it will also dump the unmatched records in the form of JSON. Now, coming to the row count and column count, it provides the row count and the column count of two different data sets. Coming to the schema validation, it will simply validate the schema. And coming to the attribute value validation, it performs multiple data validations like alphanumeric check, email checks, and the formats can be checked. Coming to the use case specific transformation cases, we mean those validations that arise by specific business requirements. So we can call them rules that differ from use case to use case and purely based on users' requirement. Some of the examples include units conversion validation, where currency conversions, numerical conversions, etc. can be verified. Now, coming to the second one, that is data threshold validation checks. It compares the user specified attribute threshold value with the user specified columns. Now, the split column validation will split the multiple columns like full name into first name plus last name, and the merge column validation will be do just opposite to that. Now, we can also verify some functional scenarios where we can verify whether some of the architectural components on the cloud, and also whether we can check that whether the bucket is encrypted or not, whether the DynamoDB table exists or not. So like these are some of the examples which we can cover in functional scenarios. Now let's move to the next slide to discuss the solution approach. Okay. So the solution approach that we have adopted, it gives users the flexibility to write and run the own DQ rules using Excel sheet. User is provided with some generic data quality rules verification as we discussed in the previous slide, and along with that they are provided with the flexibility to design their own rules as per their requirement. Now, once we are ready with our rules, next we can set some configurations in Excel for execution purpose and we are good to go. So the complete execution can be controlled just by providing some configurations in Excel. So it's quite easy to use. Datasets can be loaded from multiple data sources like S3, Snowflake, and we can extend them to many more in future. Apache Spark, along with Hadoop, is being leveraged as a processing engine to process large volumes of data. And results are being stored at a custom user-defined location on the cloud storage for future references. And also a consolidated Excel report and HTML report is readily available to the user post-execution via cloud storage and being notified to the user. So the solution is designed in such a way that numbers of data quality rules can be integrated and run in one go. Now let's have a look on the architecture of the data quality framework. On the left side, we can see that Terraform is being utilized to create all the necessary infrastructure over the cloud. So the execution flow starts with Terraform by taking pull of the code from any of the code repositories or Git, whatever you wish to. Either we can create a Docker image out of that code, or alternatively, we can simply copy the data rule engine to cloud storage. In the bottom of the diagram, we can see there is a data rule engine where user can provide all the Excel rules that they need to validate along with the required configurations. Now talking about the middle section, we can see there is cloud compute. So we have developed multiple approaches to execute our source code over cloud compute on AWS and a very efficient and effective approach to execute the same on other cloud vendors. Talking more about the multi-approach, first we have a very efficient and a cost-effective solution where we are utilizing the serverless compute, that is Fargate of AWS, to run our cloud verification scripts with minimum cost and maximum throughput. Secondly, we are using very robust computes of AWS like EMR, Elastic Container Services, and for Google we have Google Kubernetes Engine. For Azure, we have Azure Kubernetes Service and Azure Container Instances, which provides us a very powerful compute engine to execute our cloud verification scripts even on large datasets. Now, we have utilized multiple cloud resources effectively and efficiently to get the desired results. Now, let's see some advantages of the data quality framework. It ensures cost effectiveness by making sure that the data sets collected are used in processing. They are quite clean and accurate. It ensures that the data collected from different sources meets your data quality requirements. And we can make a better and faster decision by using reliable data and quickly find the business opportunities around. Businesses can use this validated data for demand planning and business forecasting. And using the validation filters, you can flag any inconsistencies before delivering it to data warehouse and govern the data in a much better way. Data is more accurate when we process this data using data quality framework, and with increased data accuracy, it ensures increased profitability and reduced loss in the long run. Data collected is easy to integrate and is compatible with most of the processes and is also easy to integrate with different tools and different cloud vendors as well. Now, let's see some of the features of data quality framework. Okay. The very first one is it supports multiple file formats that can be validated using this framework. Currently, it's supporting Avro, CSV, JSON, ORC, and Parquet file format. So the flexibility for designing the validation rules as per the requirement is one of the rich features that it provides. Now, the concurrent execution of data quality rules speeds up the execution process, and it's a great feature that helps us save a lot of time. Now, it provides the provision to terminate the job flows and workflows, and so that it releases all the resources that we used during execution and avoids unnecessary cost. Also, datasets from different sources can be completely compared using this framework, which means that whatever data we have at source and whatever data we have at target, we can completely compare row to row that dataset. One can see a consolidated execution status report in Excel as well as HTML, and user will be notified after execution, each execution, along with the HTML report URL. And the execution results will be updated in the cloud storage instances. It also supports different data sources like S3 and Snowflake. So at the end, I would like to conclude with the point that data quality framework is an approach to provide user with a cleaner and good quality data with very less effort, so as we can generate a valuable business and reputation, and we can also gain customers' trust. Thank you, and I'm open to questions if any.
Okay, so first question we have, what are all the access required to run the framework?
Okay, so talking about the accesses that are required to run this framework, we need the permissions for the cloud compute resources that we have seen in the architecture, and that is as per customers' need. And then we need some cloud storage permissions, and we need to create some relevant IAM rules and policies so that we can restrict the unwanted users and we can allow only the required users. And of course, a cloud account on the desired cloud vendor.
Okay. And second question we have, how is your infrastructure getting deployed over the cloud?
Okay, so as we discussed in our architecture also, like we are using Terraform to deploy our infrastructure on the cloud. So Terraform creates all the required infrastructure. Like what it will do is it create step functions, Lambda functions, and various IAM policies and roles that are required for the execution purpose. And it will copy the required configurations over the cloud storage. So this way, Terraform will help us to deploy all of our infrastructure over the cloud.
So thank you so much, Nisha. From this, we have come to an end of today's session. I would like to thank to all the presenters and attendees and team of Pathmakers. And in case of any questions and query, you can put your feedback and write us on pathmakers@impetus.com. Thank you so much, everyone.